Next sample problem. Aqueous solutions that contain silver ions are usually treated with chloride ions to recover silver chloride. What is the minimum volume of 0.25 moles per liter of magnesium chloride needed to precipitate all of the silver ions in 60 milliliters of 0.30 moles per liter of silver nitrate? Assume that the silver chloride is completely insoluble in water. So that's going to be our precipitate that we're going to form. Now, one change that I do want to make to this question is we're going to get rid of the 60 milliliters and we're going to change it to 60.0 milliliters. Here is the starting equation, just in case you're struggling to put together the actual formulas. So we've got magnesium chloride plus 2 silver nitrates to produce 2 silver chlorides and 1 magnesium nitrate. We've got 60.0 milliliters of 0.30 moles per liter of silver nitrate. That's this one right here. So what we can do is use that, right? We use that to actually find the number of moles that we have of the silver nitrate. So, of the silver nitrate, we've got 0.0600 liters, right? And we're going to multiply that by 0.30 moles per liter. Right? Liters cancel out. My answer is in moles. So I've got 0.018 moles of silver nitrate. So I've got 0.018 moles. Now, we're trying to find what is the minimum volume of magnesium chloride. What are the minimum moles? Minimum volume of magnesium chloride that we need in order to precipitate all the silver ions. So what we're trying to do is, that's our x. That's our unknown. So using stoichiometry, right, our unknown is MgCl2. Right? That's the number of moles x. We've got molecules. We've got silver nitrate, which is 0.018 moles. Now, in terms of the ratio, we have 1 magnesium chloride to 2 silver nitrates. So we can use this to help us find the number of moles of magnesium chloride that will actually be used in this reaction. So to find magnesium chloride again, got x over 0.018 equals 1 over 2. So we're going to bring the 0.0818 over, and we're going to get x is equal to 1 times 0.018 divided by 2 to give us the number of moles of magnesium chloride, which is 0.0090 moles. So that is the number of moles of magnesium chloride that we're going to use in this reaction. Right? So we know we're going to use that much. Remember, it's the limiting reactant, right? It's the least number of moles in our question. But it doesn't really matter. Right? But we know that we're going to have to use the entire amount because that's the least amount, and we know that's going to run out. That the minute this runs out, the reaction stops. Right? We're always looking at it in terms of the least number of moles for our reactant. So we're going to take the number of moles that we have here, right? So that is our N value, is 0.0090 moles. We've got a concentration got a concentration of the magnesium chloride, which is 0.25 moles per liter. We're being asked the minimum volume that we're going to make. Right? So the volume, that's our unknown. Right? According to the equation, C is equal to N over V. Or if we look at it in terms of the pyramid, C, N, and V, we're trying to find V. So we cover up V, and it's the number of moles divided by the concentration. So volume is equal to N over C. Our N value, 0.0090 moles divided by 0.25 moles per liter. Moles cancel out, and our answer comes out to 0.036 liters. But if we're looking at a measurement, right, if we're trying to put that in a graduated cylinder, right, we want to convert that to milliliters. I'm not going to matter, okay? I'm not going to mind if you don't put that on a test or even in an assignment to convert it to this, right? But think about it in terms of in a lab experiment. That's easier to measure in a graduated cylinder, 36 milliliters. Right, so what is the minimum volume of magnesium chloride needed to precipitate? Right? So the volume that we must have, 36 milliliters of magnesium chloride at that concentration. So do you guys see how we're using the stoichiometry? We're using the equations that we've been found, right, recently when trying to calculate molarity. And then think about what you're given in the question. Remember, moles, odds are moles is what you're trying to find in your first step. Right? You start off with your equation, try to find the moles, and then from there try to find the moles of either one of your reactants or one of your products.